Hey everyone, it's Patrick from the Babylon.js team. Welcome back to the channel. Today I want to continue our series on PBR and Node Material and talk about subsurface translucency and refraction to make an acrylic material that looks something like this. So what we have here is the final material for our dye that is this red translucent acrylic material. And you can see on these faces that we're reflecting the environment light, but we also have on these lower faces some light passing through the dye and refracting into the material. And you can see it even better when we spin to the back, and you can see these bottom faces are refracting light from our image-based lighting, while the top faces are still reflecting the environment. The other thing to note here is that because this is a translucent material, we can see through the dye to the faces on the other side, and we can see the numbers on the other side of the dye. Now, because this is acrylic and not glass, light will scatter more going through acrylic, and so the image that you see through the material will not be crisp. It'll be kind of blurry. And so what we're doing here is we're actually blurring out the textures on the back faces of this mesh. And we're doing that in a technique that we use a two-pass shader. And so in the first pass, we're rendering all of our back faces, and we're using blurred textures to render the material. And then we do a second pass where we render the front faces of the material, and all of those are using a sharp texture set. So we're going to go through how to do all of that today. So let's get started. So let me get my scene set up here. And so the scene that we have is the same starting position that we had in the other videos in the series, and we'll link all the previous videos in the description below, so if you missed anything you can catch up so that you're not lost about any of the concepts we're talking about. And we also will have the links to the starting and ending playgrounds for this video in the description as well. So the setup for this one is pretty much the same as the rest. We're using a standard PBR material in Node Material that has just kind of a white base color and is reflecting the environment. There's slight difference in this one though. We have, as you can see, already some translucency happening, some transparency happening in the opacity channel of our texture. And so what's happening though is that you can see through this mesh to the mesh in the center. And we're not seeing any back faces because by default we cull back faces. Since you normally would not see them, we don't want to render those because it's an extra render hit that we don't want to take. So we'll have to do a couple of steps in the code to render our back faces and split our shader into a two-pass shader. But we'll get to that in a second. What we're first going to start with is how to set up the nodes in Node Material. So let me roll down our materials and grab our Node Material and open up the editor. And we'll just set up our space here so we can see everything. That looks good. Okay, so we have the starting point for our shader, which is very similar to the starting point of the other playgrounds that we used before. The big difference here is that we have already loaded in a secondary texture for the blurred normal texture. So we want to make sure that we're using that on any back faces of our dye. And then we have this float that is ready to be wired up. That is going to say whether we are rendering a back face or a front face. And so we're using that much like a Boolean, where 0 means it's a back face and 1 means a front face. The other change that we made is in this numbers mask texture. And I want to show you what that looks like. So in the other playgrounds, what we did is we used this texture, and in the red channel is a mask of white numbers on a black background so that we can isolate the numbers out, which looks something like this. And what I also did is I also needed to blur this mask so that when we used the mask on the back faces that we would have a blurry version. And so I just replaced the green channel with a blurred version of this. And so we have sharp in red and blurred in green. So that should be fairly easy to keep straight. But I wanted you to see what that looks like. So jumping back to the PBR metallic roughness node, most of this is wired up already. So we have our perturb normal, which is great. View matrix, the camera position is all good. You can see the opacity is already set to 0.96. which is very, very slight transparency on the mesh. We don't want to ramp it down very much. We want a little bit so that we can see through to the back faces on the die. But if we put too much transparency into the mesh, it's not going to feel solid. And so just a little bit of transparency is enough to let us render some of those back faces on the other side of the mesh and make it still feel like it's a translucent material because we can see through it, but it is still solid. So then the next part here, we want to update our base color. So I'm going to pull the base color over here because we want to, like in the past, have two colors to blend for our base color. So we're going to start with the base color of kind of a dark gray. And the reason we're using a dark gray is that we want to rely on the transparency or the translucency tint to color the dye red. And so rather than putting a base color at the surface of the dye, I want the tint of the translucency to be what's coloring the dye. And so just using kind of a dark gray is reducing the impact of the base color for me. And then for the second one, this is going to be the numbers color. And so for that one, I want kind of a gold color. So we're going to choose something maybe in here. That's probably good enough. And then what we also have to do is blend the two colors together. So gray for the background and gold for the numbers. And so that means we need a lerp node under interpolation. So I'm going to drop this lerp node here. And remember, in the gradient, a value of 0 means left channel, a value of 1 means right channel. And we know that the numbers mask in the red channel here, which is sharp, it is a white number on a black background. So we want the gray color in the left channel and the gold color in the right channel. And then when we wire this up to base color, you'll see that we get our numbers color back, which is exactly what we need. So now the next step here is going down here. We've got our roughness and our metallic values. We're going to leave those the way they are. That should be fine. And then we're not going to put any ambient occlusion on it. Our opacity is already connected. Now we need index of refraction. So index of refraction is a value that tells us the size of the refracted image from the cube map that we are going to project onto the die. So where that comes from is every material has an index of refraction. It's something you can look up. Acrylic is about 1.47. And so that's what we're going to do is put 1.47 in here. And that is going to determine the size of the image that is refracted into the material. Because that is a constant, we don't want it to change ever. And so to save a uniform here, I'm going to change this to a constant. And that means that we don't have to worry about burning uniform in our shader. That is just going to be in the shader as a constant value. And so that is almost everything. We already have a reflection hooked up, so you can see it's reflecting our environment. But what we do need is we need some subsurface. And so the subsurface node is going to be under our PBR section. And so I'm going to bring PBR, or the subsurface node in here, and it is the same blue color as the rest of the PBR roughness metallic nodes. So it is part of that family, and you can see the icon on it is a subnode icon. And so I can only wire this up to the PBR roughness metallic node in the subsurface input. So nothing happened. And why didn't anything happen? Well, the reason being is that we're missing a few inputs here. The thickness is one of the inputs that we definitely need to have. And what thickness means is exactly what it sounds like. All of your materials have a thickness to them. A lot of materials will change thickness. So if you think about glass, it could be thin in some areas and thicker in other areas. And so you may have a range of thickness. And so you could set that up as a lerp node with a mask that tells you where it's thicker and when it's thinner. What we have here is a pretty solid acrylic dye. And so we want it to be pretty thick. And the thickness is going to determine how much influence the translucency tint has on the material. And so I'm going to set it to a value of 3. Now, if we think about it, it's an icosahedron, and it's going to be thicker in the F0 center of the die than it is towards the Fresnel edge of the die. So I could have used a Fresnel to create kind of a ramp between thickness and thinness. But for our purposes, I'm just going to use a standard single number, and that way it'll make it easier for us. So then the next part is tint color. And so I'm going to drag out a color 3 here, and we'll just call this tint color and expose it to the inspector so that if we want to change it in the future, we can just play with the value right in the inspector. I'm going to make this kind of a reddish color, a little bit brighter there. That's probably good. And then the next part here is translucency intensity. And so this is the thing that is going to say how translucent is this material. And so let me rename this to translucency intensity. And then we'll also expose that to the inspector. And then I'm just going to put this at a value of 1. And so now you see a huge change. So that was the last one that we absolutely have to allow the subsurface node to work correctly. But there's a problem. And the problem is that the numbers, which should be a paint material, are now translucent, and they're getting a tint from the translucency. And so what we need to do is adjust the translucency intensity so that it is not affecting the numbers. And the easiest way to do that is to take our numbers mask and we will need to invert it, because right now the mask is white numbers on a black background. We need black numbers on a white background. And then if we multiply that mask by our intensity, it will black out the numbers and make sure that the numbers are a 0 translucency intensity. And so the easiest way here is to get the inverse of our texture. I'm going to come up to our math section, and we want a 1 minus node. And so I take 1 minus the red channel, which will invert our colors. And then I'm going to take a multiply node, and then I want to multiply our translucency intensity by the 1 minus the red channel of our mask. And then when I put that in, it will bring the numbers back. And so now the numbers are no longer translucent. They're painted on, and so you can't see through them at all. So that sets up everything we need for subsurface. But we are missing one thing. We also need some refraction. And so refraction is also in the PBR section. And so let me bring the refraction node in. And now this one is slightly different. You can see it's still the part of the family of the PBR roughness metallic nodes. It's that same blue. It is still a subnode. However, this refraction node has to be wired into the subsurface node. We can't wire this one directly into the PBR roughness metallic node. It requires a subsurface node, which means it requires you to have the thickness, tint color, and intensity in your shader for the refraction to even work. So when I connect the refraction to the subsurface node, you're going to see that, again, we get a big change. So now we're refracting the IBL light into the material. And that's exactly what we want. But again, we have that same problem of the numbers should not be refracting anything. And so we have to do the same trick where we multiply the 1 minus the red channel of our numbers mask into it. So let's come back up here and get to a math node, and we want a multiply. And so it's going to be the same thing where we multiply our refraction intensity by 1 minus our mask, and then wire that into intensity, and now our numbers are back. So now we have everything that we need for the subsurface translucency and for the refraction. Now there's one last step here, and that step is we want to make sure that when we're rendering a back face, we're rendering a blurry texture, and when we're rendering a front face, we're rendering a sharp texture. And so we're going to do that exact same thing with a few lerps. So let me pull back our texture nodes to give us a little bit of extra space, and our front face float, which is set up just as a Boolean. And so I also need 2 lerp nodes. So under interpolation, I'm going to grab 2 lerp nodes, and there's going to be one for the normal maps and one for the mask. And so for our normal maps, again, we're saying front face value of 0 is false, front face value of 1 is true. And so we know we want our blurred texture into the left channel of our lerp node. So we're going to wire that one into the left channel and this one into the right channel. We're going to put this float right into the gradient. And then the only thing we have to do is replace wherever the normal texture was wired into originally. And if I hover over the wire, you can see exactly where it goes. So if you end up with a complex graph like we're getting here, and I'm not sure where some of these lead, just hovering over the line, the wire will show you where it goes into the graph. And so now I'm just going to take the output of the lerp node and bring it right to the normal map color in the perturbed normal, and then that should be good. So now the other part is we want the numbers mask to be using the blurred green channel when it's back faces and the sharp red channel when it's front faces. So then the blurred one goes into the left node as well, and the red channel goes into the right, and then we take our front face into the gradient. And now this one actually has two places it's wired. It's wired into this lerp node here, and then it's also wired into the 1- node. And so I'll wire this to the gradient here, and then wire this into the 1- node. And you'll notice all of a sudden our die got blurry, and that's because of this front face. So if I set this to a value of 1, it's going to be sharp. If I set this to a value of 0, it's going to be blurry, and that's exactly what we want. So now we are done with our material itself. And so if I roll around here, you can see we have all of our refraction that we wanted. I can come into the right node mat and scroll down to where we have our inputs for the shader, and then change our front face to 1 right here. So we can test that out right in the inspector, which is really great. And then the last part is we have to enable our back faces. So let me go over to this other playground where we can enable this quickly, so that if I reload the playground without saving the shader, we're going to lose all of our changes. So I have a separate playground here set up so that we can experiment with the code now. So the first thing we need to do is we need to tell the scene that we want to render back faces on this specific mesh. And so if I come up here, I've got it already highlighted. And so we want our backface culling to be false. And so if I uncomment that line and I run our scene, you're going to see something that's really strange. This doesn't look at all like we want it to. And the reason being is that we are rendering back faces on a mesh that has some transparency to it. And so what happens is, because we don't know where those faces are in depth, we can't sort them correctly. And so it doesn't understand which is a back face and which is a front face, or which is in front of the other one, because of the fact that there is some transparency on the mesh. And when we do this, that's when we have to start getting into the 2-pass separate render pass or separate culling pass for the material, so that we can get the faces to correctly render in the right order. And so the way to do that is I'm going to uncomment this next line, which is setting the separate culling pass to true. And now when I run that, you'll see it gets right back to exactly what we expect. So this now has our separate culling passes. And if you come in here, you can see already, I can see through the die and I can see the back faces rendering, but they are completely sharp. And so I don't want to have the sharp numbers, because it'll make it feel more like glass, like there is some refraction going on, but because it is so sharp, this is not acrylic. And so we want to make sure that we get the blurry textures, which means that we need to set our front face on the first pass where it's rendering the back faces to false. And then on the second pass where it renders the front faces, we set our front face value to true. And so the way we do that is, the first thing we want to do is we have to call a couple of observables. The first one is the on before render observable. And so what that is doing is saying, before we render, I am going to go in and set my front face parameter in that shader to be false. So that means that before we render everything, we are setting it to be blurry textures. So now when I run that, you're going to see everything is blurry because we set it to blurry, but then we didn't change anything in between the two render passes. So to get in between the two render passes, we added a new observable, and you can play with it right now in preview, that is called on-between pass observable. And so what that says is, after I do the first pass, I can tag that observable to do something before I do the second pass. So now what we're doing in this section is the important part. So let me walk through it. So we're going to first set our front face value to 1 or true, meaning now we want to use sharp textures on the front faces. But we also have to do a couple of extra things. So because we are rendering a second mesh, we have to grab that sub mesh to make sure that that one is the one we are applying it to. And so the other part of this is that when we do a 2-pass shader like this, we cache the material. And so it's going to use the exact same material over and over again, which means it doesn't matter what I do in this observable. If I change the parameters in the material, I have to then discard the cache material or we won't see those changes. And so the scene reset cache material will get rid of that cache material so that we can recompute the shader with the new parameter and then render it a second time. And then now that we have it, now that we've killed the cache material, we now have to reattach this material back to that mesh. And so once we got our submesh, we now have that mesh again. And the bind for submesh is taking the mesh world matrix and the mesh itself and saying, okay, now assign this back to that mesh. It's a little complicated, but this is the best way to make a change in the shader in between passes. So now when we render this one, you can see we get our sharp front faces again. And if I zoom in here, you can see we are definitely getting blurred textures from the back faces. So that is basically what we're going to do for the acrylic material. Is it's a matter of setting up your node material with a subsurface node, a refraction node, and then we're using this 2-pass system just for the purposes of making the acrylic look believable, and then tying into our new on-between pass observable so that we can change the shader and make that tweak so that we get both the blurred back faces and the sharp front face textures the way we want them. So I hope you've enjoyed the series so far. If you have any questions, please leave them in the comments below. If you're enjoying this content and you want to make sure that you're always notified, please drop a subscribe and hit the bell icon for us. And if you have any other questions about Babylon in general, please reach out to us either in the comments below or on our forum, and we'll be happy to talk with you. I hope you enjoyed it. Take care.